Hello and welcome, dear Mathletes, once again to Mathlete Minds. We continue our journey of similar triangles, and in this particular video, we'll focus on concept and action questions. Now, what are the concepts that we have learned earlier? The concepts that we have learned earlier is BPT, contours of BPT, SSS, and the three golden criteria, namely AAA, SSS, and SAS. So we'll see the applications of these concepts directly right now. The questions that we may be doing will not be directly from the book, but of course, if you understand these questions thoroughly and how to apply these concepts, you will be in a better position to handle any question on similarity of triangles. To begin with, we start with a real world similarity. Here we have a shadow and pole puzzle. That is, you are given a street light and there is a pole adjacent to it on the same plain ground, and they have different heights. They are casting, definitely they will cast different length of the shadows. So now, to find out what is the height of the pole, if the height of the street light and the length of the shadows cast by each of them is given. Mathematically, we can represent them in this manner. Important thing to keep in mind over here is these two angles, that is the street light and the pole, they are taken as vertical structures. So the angle they make with the ground is taken as 90 degrees. The angles at the top over here, that is where we have the top of the street light and the top of the pole, at the same instant of time, at the same time of the day, the angles made by the rays of the sun will be equal. So if we position them this way, you can see here that these two angles are 90 degrees. Angle A corresponds to angle C, corresponding angles because these are parallel, and angle E is a common angle. So we get here all the three angles of triangle ABE equal to the three angles of triangle CDE. So we can conveniently write triangle ABE is similar to triangle CDE by AA similarity. Once you have written by AA similarity, you can write the proportionality relation of the sides. Here we have taken only two sides into consideration because we need only them. So AB by CD is equal to BE by DE, where AB is the height of the street light, CD is the height of the pole, BE is the length of the shadow cast by the street light, and DE is the length of the shadow cast by the pole. Now, in this particular question, height of the street light is given as 7 meters. This is given as 7 meters. Height of the pole we are supposed to find out. And length of the shadow cast by the street light is 10 meters, and the length of the shadow cast by the pole is 4 meters. So on cross multiplication, we get H is equal to 28 by 10. That is equal to 2.8 meters. So the height of the pole is equal to 2.8 meters. So this is how we need to find out. Supposing you are given some other values which are missing instead of the height of the pole, that can also be found out in this manner by putting the other values and finding the unknown value that is required to be found out. Moving on to the next question, we have here, measuring the unreachable using only alignment and similarity. So here you can see this child, the student, was supposed to measure the width of the river without actually going into the water. So what he does is, he stands at a point A and he locates a tree directly on the opposite bank over there. So next thing what he does is, he positions himself directly in line with this tree that is on the opposite bank. So mathematically we can check it out this way, and then he starts walking completely in a straight path along the bank of the river to a point B. And this point B is at a distance of 12 meters. So he walks till the point B and reaches this point B, which is at a distance of 12 meters. At the point B, he puts a marker over there, and then he proceeds from B to C, and B to C, the distance that is given is 4.5 meters. So he walks another 4.5 meters from B to C. Then from the point C, he turns vertically away from the river, and this angle that he turns over here is 90 degrees. And he walks straight completely to a point D. Now, how does he locate this point D? As he walks, he keeps looking behind and finds out a point D such that when he looks back, the point D, B, and the tree on the opposite bank They are in a complete straight line. So once you locate that point, but if you look at this figure over here, we get two similar triangles here. Basically, this angle will be equal to this angle, vertically opposite angles. And this angle is 90, this angle is 90. So we get triangle DCB. Triangle DCB is similar to triangle TAB. Triangle TAB. Because we have angle angle C, this is equal to angle A 90 degree. These form a pair of vertically opposite angles. So now we can write the proportionality relation of the sides. DC by TA is equal to CB by AB is equal to DB by TB. DB by TB. Now we need only the first two ratios, DC by TA. DC is walking a distance of 7.5 meters. So 7.5 by TA, which is the width of the river, we have to find that out. CB is 4.5 and AB is 12. So TA, or the width of the river, will be 7.5 into 12 by 4.5. So if you simplify this, 15 threes, 15 fives, 3 fours, so you get here 20 meters. So the width of the river approximately is 20 meters. Now if these measurements are done, say up to 2 decimal places or 3 decimal places, there can be further accuracy in the width of the river. But approximate idea about the width of the river can also be obtained even if we have 1 decimal place, or even there is a no decimal place over here. So this is how the width of the river can be actually measured without going inside the river. The next question pertains to right angle triangle. So here we have a triangle ABC, which is right angle at the point A, at the vertex A. And AD has been drawn perpendicular. So the moment we draw a line perpendicular in a right angle triangle, we create 2 more right angle triangles. And the best part is all these 3 right angle triangles are similar to each other. To understand this, let us take the triangle BAD and BAC, the big triangle. Now in the small triangle B, angle B is the common angle for both the triangles BAD and BAC. Then angle A is 90 degree, angle D is 90 degree. So for the small triangle BTA and the big triangle BAC, we have the similarity criteria. That is, we can write down triangle ABC. Triangle ABC will be similar to triangle DBA. DBA by AA criteria. Because we have angle A, that is 90 degree, is equal to angle D, that is 90 degree. Angle B is the common angle. And the third angle, this is the third angle over here, and this is the third angle, that is ABC. This angle is over here. So these two angles become equal. So we get here. Then if I take the triangle CAD and the triangles ABC. So in this case, also in a similar pattern, we can write ABC is similar to triangle DAC. DAC. So again by AA criteria. Now if we can see over, we can see here that ABC is similar to DBA and ABC is similar to DAC. So conveniently I can write down triangle DBA is similar to triangle DAC. So if we write down the proportionality relation, DB by DA is equal to BA by AC is equal to DA by DC. So now we have to prove BD into CD is AD square. So I'll take this ratio and this ratio. We get here DB by DA is equal to DA by DC. So cross multiplying, we get here DB into DA is equal to DA square. Or we can write it down as BD into CD. This will be CD. BD into CD is equal to AD square. So this is what was supposed to be proved. Important thing again is you have to be very careful by identifying the triangles which are similar. This order of writing down the similarity criteria is very important. If the angles are not in sequence over here, the correct angles, corresponding angles are not in a proper sequence, the whole proportionality relation will go incorrect and you will never get the desired result. So before you proceed ahead, just check on that the similarity criteria holds true and the correct angles are written in the proper order over here. This is the next question, which is based on the previous question, similarity of two right angle triangles. We have to get the value of AD. So here I can take the two small triangles and write down triangle BAD. Triangle BAD is similar to triangle ACD. Triangle ACD. BAD is similar to ACD. So BA by AC is equal to AD by CD is equal to BD by AD. Now we have to find the value of AD. So I'll take these two relations over here, AD by CD. CD is given as 8 and BD is given as 2 and AD is not known. So AD square on cross multiplication is 16. So AD will of course be plus minus 16, but we are measuring the altitude over here of the triangle. So we'll take here plus 4 centimeter. So AD measures plus 4 centimeters. So you have to write it down this way. So again, here you have to be careful in which two the angles are equal. So remember, when you get these type of triangles, this angle B will be equal to this angle over here, and this angle A will be equal to this angle C over here. Moving on to the next question, here we have a quadrilateral where AB is parallel to DC. Now in this quadrilateral, it is mentioned that we have AC and PQ intersecting at the point A. Now we'll focus on the triangles that are formed, the triangle AOP, the triangle AOP, and the triangle COQ. Now if you look at the figure carefully, angle AOP will be equal to angle COQ. Why? The reason behind being vertically opposite angle. These two are intersecting lines. The moment we get any two intersecting lines, the vertically opposite angles are equal. Then AB is parallel to CD. So we get here this angle A is equal to this angle C over here. Interior alternate angles. So I can write angle PAO is equal to angle QCO. A pair of interior alternate angles. So now we can conveniently write triangle, these two triangles AOP is similar to triangle COQ by AA criteria. AOP, this order of COQ, C is equal to A, O and O are equal, so we get this relation. So if I write down the similar proportionality relation, I'll get AO by CO is equal to OP by OQ is equal to AP by CQ. We have to prove OA into CQ. So I'll take this ratio and this ratio and cross multiply them. So AO into CQ is equal to CO into AP. And here it is given OA into CQ, so you can just rewrite this OA into CQ is equal to OC into AP. So this is what we are supposed to prove. The next question here is, we have a triangle here where you find there are some extra constructions have been done. Like you can find there is a point D on this and there's a point E on the side BC, and a line has been drawn which has been extended to F, and then AC has been extended to meet at F. Another construction that is done is CG has been drawn parallel to DE. So it's not mentioned over here, but it's given here angle BED is equal to BDE. So of course this is the initial figure. Extra construction that we need to do is draw CG parallel to DE. That is the construction that we have to do. The figure is originally given in this format. Now let us focus on BED is equal to BDE. Now if BED is equal to BDE, then these two angles are equal. So triangle BDE will become an isosceles triangle. Because if the base angles are equal, the sides subtending the equal angles are equal. So we can conveniently write BD is equal to BE. But it is also given E is the midpoint of BC. So BE becomes equal to EC. So the three of them are equal. Now let us take the triangle BCG. CG is drawn parallel to DE. So if we take the triangle BCG, by applying this BPT, we can write down BD by DG is equal to BE by EC. But BE is equal to EC because it is the midpoint. So this becomes this BE by EC is equal to 1. So BD is equal to DG. BD is equal to DG. So here I can write this is also equal to DG. That means all the four of them are equal. BD is equal to BE, BE is equal to EC, and it is equal to DG. So these four the same distances are equal. Now let us focus on the triangle ADF. In the triangle ADF, we are given here by construction CG is parallel to DE, and DE has been extended to the point F. So it is a straight line. So if we focus on the triangle ADF, we get here, because by BPT we can write down here AG by GD is equal to AC by CF. So if we add 1 to both the sides of this proportionality, plus 1, AG plus GD. AG plus GD, if you look at the figure, you get here AD by GD is equal to AC plus CF becomes AF. AF by CF. So AD by GD is equal to AF by CF. But we have to prove AD by BE. Now BE is equal to GD. BE is equal to, so I can just replace here AD by BE is equal to AF by CF. So this is what we are supposed to prove. So here you can notice twice we applied BPT. The same thing, if you want, you can do it even with similar triangles. DC has been drawn parallel to DF. So we have a triangle AGC is similar to triangle ADF. And then you write the proportionality relation of the sides, and from there subtract 1 to get this relation. So that can also be done. The next question over here, you can see that we have a number of triangles drawn within each other, and but the important thing is we have to we are given here the first big triangle, that is OBD, which is of course a right angle triangle. Now why do we take it as a right angle triangle? Because OB is the perpendicular bisector of the line segment DE. So DE is the line and OB is the perpendicular bisector. That means this angle is 90, this angle is 90, BE is equal to BD. So because it's a perpendicular bisector, we can write BE is equal to BD. Now, if I take the triangle, focus on what we have to prove. We have to prove 1 by OA plus 1 by OB is equal to 2 by OC. So I'll consider here the triangles where we get OA, OC, OB. So I'll take OAF and OBD. Triangle OAF and triangle OBD. Now in these two triangles, angle O is common, angle A is 90, angle B is 90. So OAF is similar to OBD by AA criteria. So we can write down the proportionality relation OA by OB is equal to AF by BD is equal to OF by OD. So this relation we get, number one relation. Now let us take the triangle ACF and the triangle BCE. Now in these two triangles, triangle ACF and triangle BCE, they have this pair of vertically opposite angles equal. This angle is 90, this angle is 90. So ACF is similar to BCE by AA criteria. ACF, check the order, ACF is similar to BCE. So if I write down the proportionality relation, AC by BC is equal to CF by CE is equal to AF by BD. So now we are over here, OA by OB is equal to AF by BD. Now look at these two relations over here. BD is equal to B, so I can write this also equal to AF by BD. So that means basically all the three ratios over here are equal to the three ratios here, because AF by BD is equal to AF by BE. So now we come back to the ratio over here, AC by BC, because AC by BC will help us get the desired result. AC by BC is equal to OA by OB. I'll take this ratio along with it. Let's get back to it and see. This was OA by OB and AC by BC. Now all of them are equal to AF by BD, so we can relate all of them. AC by BC will be equal to OA by OB. Now why we are taking this? Because we have to get here OA, OB and OC. AC can be written as OC minus OA and BC can be written as OB minus OC is equal to OA by OB. On cross multiplication, we get here OC into OB minus OA into OB is equal to OA into OB minus OC into OA. So if we put in the OA into AB on the same side, we get here OC into OB plus OC into OA is equal to 2OA into OB. So divide both the sides by OA, OB. So here I will get OC by OA plus OC by OB is equal to 2. Now divide both the sides by OC. So we get here 1 by OA plus 1 by OB is equal to 2 by OC. And this is what we have to prove. So what are the things we have to keep in mind? First of all, focus on the triangles that you really need. If you take other triangles which are not required, like if you are taking OAF and CAF, you wouldn't have reached the proper result over there. And they would not, of course, one angle is 90 over here, but otherwise they can't be proved as similar. So check out the proper triangles that you have to take and see how to form the relations there and how to equate the proportionality relations. The next question is, if PQRS is a parallelogram and AB is parallel to PS, then prove that OC is parallel to SR. So first of all, PQRS is a parallelogram. So getting back to the properties of parallelogram, PS will be equal and parallel to QR, and PQ will be equal and parallel to SR. That is the property of the parallelogram. So now AB is parallel to PS. So we'll start from this portion. AB is parallel to PS. And we'll consider the triangle OPS and OAB. OPS, triangle OPS and triangle OAB. Now these two triangles will become similar because this is parallel to this. These are the corresponding angles. So the angles become equal. Corresponding angles are equal. So they become similar by AA criteria. So we can write the proportionality relation of the sides. OP by OA is equal to PS by AB is equal to OS by OB. This is the proportionality relation. Now, if I take the triangle CQR and CAB, QR is parallel to PS and PS is parallel to AB, so QR will be parallel to AB. So CQR is similar to CAB. CQR, triangle CQR is similar to triangle CAB. So these are parallel. So we get here corresponding angles. So both these corresponding angles are equal and angle C is common. So by AA criteria, we get these two triangles also similar. We can write CQ by CA is equal to QR by AB is equal to CR by CB. So this is the second relation. This is the first one and this is the second one. Now PS by AB and QR by AB. PS is equal to QR. So I can say here that CQ by CA is equal to CR by CB. This is also equal to PS by AB. because QR is equal to PS. So we get here OP by OA and is equal to PS by AB is equal to OS by OB, OS by OB is equal to, all of them are equal. So now since we have to prove SR is parallel to OC, we'll take OS by OB from here and write OS by OB, OS by OB, and from here we'll take CR by CB is equal to CR by CB. So we can reciprocate it and write as OB by OS, right? OB by OS. Or let us OS by OB is equal to CR by CB. So this is what we are getting here. OS by OB is equal to CR by CB. If we reciprocate it, we get here OB by OS is equal to CB by CR. Now if we subtract 1 from both the sides, OB minus OS is BS. So we get here BS by OS is equal to CB minus CR is equal to BR by CR. So what are we getting? BS by OS is equal to BR by CR. Now if you look at the triangle OBC, in the triangle OBC, BS by OS is equal to BR by CR. So conveniently we can apply the converse of BPT. In this triangle we have these two sides, like BS by OS is equal to BR by CR. They are being proportionately divided. So we can say that this implies that SR is parallel to OC by converse of BPT, not BPT, by converse of BPT. Moving on to the next question, the side BC of a triangle ABC is bisected at D. O is any point on AD. O is any point on AD. BO, CO, and CO meet AB and AC at E and F respectively. AD is produced to X such that E is the midpoint of OX. We have to prove AO by AX is equal to AF by AB. So what are the things we have given here? The side BC of a triangle. This is the side is bisected at the point D. That means D is the midpoint of BC. O is any point on AD. O is any point and BO has been produced to E, CO has been produced to F. Another important aspect that we are given here is AD has been produced to X such that OD is the midpoint of OX. Now, if you look at the figure BOCX, you find that this is a quadrilateral BOCX. But here we are given D is the midpoint of BC, so BD is equal to DC, and D is the midpoint of OX, so OD is equal to OX. That means BOCX becomes a parallelogram, because it is the property of a quadrilateral that if the diagonals bisect each other, then it is a parallelogram. So here we can see that the diagonals are bisecting each other. They're dividing equally, each of them are dividing the other diagonal equally. So we can say that BOCX is a parallelogram. BOCX is a parallelogram. Now once it is a parallelogram, BO is parallel to CX. BO is parallel to CX and CO is parallel to BX. CO is parallel to BX. So now if BO is parallel to CX, right, and CO is parallel to CX, we have to prove this relation AO by AX is equal to AF by AB. So let us focus on the triangle ABX and the triangle AFO. Now we are getting here OF is parallel to BX. How do we get that? CO has been produced to OF, to the point F. It is the same straight line. So if CO is parallel to BX, I can also say that OF is parallel to BX. So considering the triangle ABX, in the triangle ABX we have here OF is parallel to BX. So if we can categorically state that triangle AOF is similar to triangle AXB. So I can write down AO by AX is equal to AF by AB. So important thing that we had to do in this question was we had to first talk about the parallelogram over here. And why it becomes a parallelogram? It becomes a parallelogram because the diagonals are bisecting each other. In any quadrilateral, if the diagonals bisect each other, it is a parallelogram. You can prove it also. Now, once it is a parallelogram, we know that in the question, CO has been extended to the point F and BO has been extended to the point E. So that means if CO is a parallelogram BOCX, CO is parallel to BX, then CF is also parallel to BX. So we consider the triangle ABX to prove this, and in this triangle ABX we get OF is parallel to BX. So OF is parallel to BX, so that means we can write down AF by AB. The two triangles, we can take them similar, the corresponding angles are equal, so we can write down AF by AB is equal to AO by AO by AX, which is supposed to be proved here. And if you want to write it down with the help of BPT saying this is parallel to this, you can do that. Then you will get AF by FB is equal to AO by OX. You have to reciprocate and add 1 on both the sides to get this relation. So it's better that we apply here similarity of the triangles by AA criteria. We get triangle AOF is similar to triangle AXB. These are corresponding angles, so AA criteria. So this is the much easier option over here. If you want, you can do it with BPT. There is no restriction on that. Any method can be taken in use of. So with that, we come to the end of this video. If you are committed to learning, please subscribe to the channel. If you find it helpful, like it. And if you believe in sharing knowledge, please share it. Hope that you like, subscribe and share the channel. Thank you very much for watching.